Okie dokie, final example. Here we go. This time we are taking that same yellow region, but we are rotating it about the line x equals 3. And that's a vertical line, so your representative rectangle will go perpendicular to that, which means it goes horizontally, which means this is going to be a dy problem because the thickness of the rectangle is along the y-axis. And also, rectangle does not touch the axis of rotation, therefore it's a washer problem. All right, that means we also have an outer and an inner radius, so let's figure them out. Our outer radius, it goes between the axis of rotation and the outer edge of the rectangle, but it's always right minus left. And so on the outer is x equals 3, and on the left side is going to be x equals the square root of y over 2. Remember, since it is a dy problem, you're going to want to take this parabola and solve for x. And again, that doesn't simplify, so that's our outer radius. Our inner radius will go between the inner part of the rectangle and the axis of rotation, but right minus left means on the right is x equals 3, and on the left is x equals 2. That makes our inner radius a constant of 1. And so then plug it in. Volume is pi times the integral of big R squared minus little r squared, and then dx or dy. It's a dy problem, so we're going to go along the y-axis, and it goes from 0 to 8. So there's our limits, and then we work it out. Now this one becomes a little messy to work out by hand, but it is doable. First thing is, you're going to want to expand that all out. So if you do, you get this. And this term right here, the y and the 2 are in a square root. If I split them up, put the square root of y over here, and the square root of 2 under the 6, this fraction actually simplifies kind of nicely if you rationalize the denominator. So that's what I've done over here in blue. Multiply top and bottom by that square root, and you can see we're going to get 3 root 2. It's a little nicer because there's not a fraction. So I just rewrote this as 3 root 2. And that, I didn't do anything to go from this line to this line. So then it's power rule. So I went ahead and did the power rule to find the antiderivative. And then we got to plug in. And right here is kind of nice if you recognize something. We got 2 root 2 times 2 root 2 times 2 root 2 times 2 root 2 because it's cubed. We have 2 root 2 4 times. And if you recognize the square root of 2, or sorry, as 2 root 2 as the square root of 8, then it becomes really easy. Square root of 8 to the power of 4 is going to be 64. Otherwise, you can work it out the longer way. Raise 2 to the power of 4, raise the square root of 2 to the power of 4, and multiply those together. But you do get 64, and this one does simplify down pretty nicely. Okay, that's it. That's volumes by discs and washers. So have fun with playing around with calculus. Bye.